Hi guys, this is the third lesson of Managerial Economics, demand estimation and forecasting. First, we are trying to estimate the demand function, and then we are going to use it in order to forecast the demand for the future periods. Okay, so the empirical demand function. Empirical demand function, the word empirical means evidence-based or observable. That means we are taking a quantitative sort of analysis in order to estimate the demand function, the demand line. So we are using regression analysis in here. As you know, regression analysis helps us to obtain the particular function related to a curve or the line. So in estimating the demand function, the functional form, the correct functional form is necessary. So we have the linear functional form and the nonlinear functional form. So the regression line for a linear functional form and a nonlinear functional form is very much different. So if you assume a different functional form, then the amount, the error term you're going to be left with will be higher. And if you know about econometrics, then the R squared or the goodness of the fit of the line will be less. That means the data will not actually fit the line or the regression line we have obtained. So the correct functional form is necessary in order to obtain a proper regression line for demand. So in here, we have the basic function of a demand curve, that is quantity demand equals A, the intercept, plus BP plus CM plus DPR plus ET plus FPE plus GN. P, B, C, D, E, these letters in simple are the slopes, while the other terms is P is price, M is income, PR is the price of related goods, T is the taste or preference of the consumers, PE is the expected price, and N is number of consumers. So taste and the expected price of the consumers is difficult to quantify because that information is hard to obtain and hard to measure. So why, normally the relationship between price and quantity demanded is negative, but in here it's given as positive. The reason is that, so according to the good, actually, according to circumstances, according to the product, we are going to estimate, the sign may change. Therefore, we are just assuming it like this. If we take the price of a related good based on whether it's a complementary goods, a substitute, or a non-related goods, the sign may change. Even in income, for some goods, when income increases, the demand increases. For in some good, the income increases, demand decreases, like in given goods. In the same way, when the price changes, the impact on the quantity demand may be positive or negative depending on the circumstances. Okay. So when defining and collecting data for demand estimation, we need to consider numerous factors. First, recognition of geographical boundaries of products market. So certain products have the information related to those products. Maybe the income information. So depending on the geographical factors, they may change. When it comes to income, as you know, different districts, the per capita income may change. according to district, province, and whatever. So prices of all related goods, substitutes, and complements should be considered. So when estimating demand function, we have to consider all the related goods. We cannot just take one substitute or one complement as per our liking. We have to get all possible related goods, all applicable related goods. Then knowledge regarding the market condition. Is it growing, shrinking? Like so, the economic condition have a certain impact on some of these factors. The income, the population growth, they are depending on the economical factors. So the market condition, the economic state should also be considered when estimating the demand function. Next, what can a manager do to select the correct functional form? As I said earlier, the correct functional form is necessary in order to obtain a proper regression function. So therefore, to assume a correct functional form, the managers can follow these things. First, the manager may consider the functional form used in similar empirical studies of demand. So let's say the manager is manager of a coconut oil company. So for a similar product, another coconut oil company, the functional form they have used to analyze their demand estimation, the manager may assume the same functional form and conduct their studies for their product. Then the information or experience that indicates that the demand function is linear or non-linear. So according to the manager's own experiences and the information he has, he can assume the functional form. So if you get the data, if you get it to a curve, you may be able to sometimes clearly see what is the correct function, whether it's linear or a non-linear functional form. And sometimes researchers may test using several regressions. The manager can also use several regressions, the non-linear form as well as the linear form. As you know, in EVs, you can run the regression line in the log form, the non-linear form, as well as the linear form, and see how the goodness of it changes. You can see what is the most applicable regression functional form to the function. Then estimating demand for a price setting firm. A price setting firm is a firm that is able to set their price. They're not a price taker. They set their own prices. So we are taking the example of pizza demand. Okay, based on the product, the time we are considering, and if it's a time series data, the time we are considering may depend. So some products from month to month, their prices may change. For some products, there can be seasonal changes. Some products, the demand and variations do not take place for years. So accordingly, the time period we have to take will depend. For a product that have seasonal changes, you might have to take in quarters. For products that they have daily changes in demand, might take the changes for each day. Likewise, in pizza, a product like pizza, we can change for a year, a month, because usually a pizza demand does not usually change according to season. But if you assume there's seasonal changes, you can take demand changes for a season. Okay. So here the variables we are going to consider are prices charged by the competitors, average household income from the region, and the price of the Big Mac for last 24 months. So Big Mac is a substitute. And we have a competitor, price of a competitor, price of a substitute, which is Big Mac, and the average household income from the region. Should adjust price and income data for the effects of inflation. So the inflation, the income and the price, as you know, changes with the inflation. So these inflationary changes should be adjusted, because if the income and the price have changed for inflation, due to inflation, then it might not impact much on the demand for the product. So those kind of factors should be adjusted to inflation. We do not consider the number of residents in the region because it doesn't seem like a factor that could affect the demand of a product like pizza. So depending on the product, we have to consider the factors. So in pizza demand, we cannot take population. For something like maybe gas, um, coconut oil, for products that actually changes with the population, demand changes with the population, you can get the variable population, but for something like pizza, you cannot take the population, because just because the population is increasing, you cannot say that the pizza demand will change. Because pizza demand depends on the consumer's preference, their taste, as well their own likings, their income levels, whatever. So here is the results after the regression. Here the R squared is 0.955, which is a greater value. R squared is equal to 1, which means the goodness of fit. That's a perfect goodness of fit. That means the data, the variables perfectly completely determine the quantity demanded. So R squared closer to 1 means the goodness of fit is well, that means the error term is reduced, means that's 95%. 95% of the variation in quantity demanded can be explained to the variation in the factors we have considered for the estimation. As you can see, the p-value is less, probability is high, the F ratio. P-value is less means the probability of this is high, F ratio is high as well. So in here, the A term, intercept, is this one. Here, the t-values. The t-values, the t-statistics are high for everyone, every factor. If we take the rule of thumb is 2. So each factor is, the t-stat is greater than 2. And the p-values are sort of a considerable amount. So by this, we have estimated the demand function. We have got the same values, the parameters, get those, and do this. So we have assumed different values for price, income, AR, the price of the related goods with the competitor's good, then the Big Mac, price of Big Mac. Okay, so accordingly, by using the estimates we have gotten, the parameters we have gotten, and by substituting the values we have assumed, we have obtained that the quantity demand here will be 2784.4 units. Okay, then we are going to calculate the elasticities. We have the price elasticity of demand, income elasticity of demand, cross elasticity of demand. So elasticity, price elasticity of demand, it is the responsiveness of quantity of demand for a percentage change in price of the considered good. Income elasticity of demand is the responsiveness of a quantity of demand of the considered good for a percentage change in income of the consumer. While cost elasticity of demand, it is the responsiveness of quantity of demand for a percentage change in the price of a related good. So here we have the formula for price elasticity, for income elasticity, as well as cross elasticity. By substituting those values, we can obtain the price elasticity, which is minus 0.694. A price elasticity of minus 0.694. Usual price elasticity is minus because there's a negative relationship between price and the quantity of demand. And a value which is less than 1 shows inelastic demand. We cannot say perfectly inelastic because it's not 0, but it's between 1 and 0, so it's inelastic. Then we have the income elasticity of demand of a pizza, which is 0.871. 0.871 is still, it is a positive value. So that means it has a positive relationship between there's a positive relationship between quantity of demand and income. So it can be a normal good, means essential good, or a luxury good. Even in here, it is inelastic because it's not greater than 1. Then cross elasticity of demand. Cross elasticity of demand is 0.369, which is also inelastic. In the satisfact, it is positive. This positive means it's a substitute. When the price increases, the quantity of demand increases. So the competitors good as well as here is they are substitutes. And in same process we can get for Big Mac. So Big Mac is also a substitute because there's a positive cross elasticity of demand. It's 0.030. We say substitutes are perfect substitutes if the cross elasticity of demand is like 1. So if the price changes by 1%, quantity changes by 1%. Okay, this is this is the same example, but we have used assume the nonlinear functional form. So this is the log form, log So in here, the R squared is 0.9495 something. F ratio has reduced compared to the linear functional form. R squared has slightly reduced. And here, if you are seeing the nonlinear functional form, as you can see, the stat for the intercept is not significant. It has become non-significant here. If we assume the nonlinear functional form, that means we cannot actually include A in intercept. So the thing about using log form is that if you are using log form, the values you get for the parameters actually indicates the elasticities. So it is log P, the parameter you have obtained 0.662. It is the price elasticity. Yeah. We have already calculated the price elasticity and cross elasticities, income elasticities. These values are similar. So if we get the log form, we can easily obtain the elasticities. Why are they similar? As you can see, if you kind of expand this thing, the change in log of Q, change in log of price, if you expand it, you have to multiply the denominator and the numerator by 100. Then, as you can see, you're obtaining the formula for elasticity. Okay, now we'll go to demand forecasting. So in a time series data, the response variable is taken in relation to time. Okay, so if we are not taking a time series data, um, so the first example we took, the pizza demand, so that's not a time series data because the independent variable is not time. Okay, so it's not a time series data. In such a cases, we get the regression line and we can assume what the factors will be and forecast the demand accordingly, get the value for the demand. Like we did in the example by assuming different values for different parameters. So in here, we are going to take the time series data. So according to the time, we are going to take time as the independent variable and the response variable. And the response variable, that is quantity of demand, is taken in relation to the time. So here, in here, we have business statistics. As you know, time series data, there are 4 components. There's the trend component, seasonal component, cyclical component, and the residual component. So these components are used to explain the change, the variation in the response variable to time. So sometimes we might, we can take the multiplicative approach or the additional approach. Multiplicative means we assume that the variation occurs from trend component, from these four components getting multiplied together. And in additional approach, we assume that we are adding these components together in order to create the result for the variation. So these components are used to explain why the response variable has changed, with the predictor variable being time. So here, secular trend for the trend component. So in trend, we say we take the long-term movement in data. So if you get a curve, here you can see there is a positive linear trend, can be a linear trend or a nonlinear trend. There can be positive linear trend, there can be a negative linear trend, or a nonlinear trend. Seasonal components. Seasonal components is the variations in data that repeats itself. So let's say example, every year in April, the sales of the ready-made garments in Sri Lanka, the demand for ready-made garments increases. So that's a seasonal variation. Cyclical fluctuations. To observe a cyclical fluctuations, you have to take data, time-series data for a long period of time. Maybe the economic changes, economic recessions, economic growth, political changes, agricultural conditions. You have to get a long period of time to observe the fluctuations, observe the change. Then we have the irregular variations, residual components. So if the response variable is changing due to unexpected changes, unusual circumstances, maybe natural disasters, strikes, major changes in product and services. Likewise, unexpected changes, then it would say that it's a residual component. Okay. Then there we have two main forecasting techniques. We can use averaging techniques and we can use trend projection. In trend projection, we are using the amended regression model. Amended regression model means we have the normal regression function, which is y equals a plus the other term. So in here, what we are assuming to obtain this regression model is that we take the independent variable as time and the response variable will be quantity of demand. So we are going to see how quantity of demand, how much of the variation in quantity of demand can be explained through the variation in time by getting the amended regression model. You can easily do this using E-waves. So if you have a time series data, you have your factor, the estimate called year or maybe months component. You can get it as the independent variable and the dependent variable as quantity of demand, and you can estimate the time series regression model. Then you can easily assume, you can easily forecast for the future periods by changing the value for term t, the factor t. Then the averaging techniques, the simple moving average and the weighted moving average. So simple moving average. The arithmetic average of the data set for previous period is used to analyze the trend and thereby forecast for the following periods. So why it is called as moving? So moving means when a new data, when we get a new set of data, the oldest data set is dropped. That is why we call moving. Simple in here is because we assume the same weightage for each period of data. So here's an example of a simple moving average technique being used. So 4MT means 4-point moving total, 2-point moving total, and the moving average. So we can take a odd moving average value. So if we have a 3-point moving average, we can go for 3-point. If we get 3-point moving total, we can go for 3-point moving average directly. But when it comes, if we get a point, even moving average, then we have to use the 2-point moving total before we obtain the 4-point um, that are even numbers moving average. So in here, 174 is taken by adding quarter 1, quarter 2, quarter 3, and quarter 4 production values. Then 177 we obtain by adding 41, the quarter 2, quarter 3, quarter 4, and quarter 1 values, quarter ones of the next year values. As you can see, when we go to the for 177, we have dropped the quarter 1 value, production value. That is why we called moving. And average, because after we get this value, the moving total, we divide it by the amount of points to get the average value. So in here, in a even number for moving average, as you can see, 174 and 177, they are not applicable for any quarter. They are lying in between these quarters. That's why we are taking the 2-point moving total. And when we get the 2-point moving total, as you can see, the 351 lies in parallel with the quarter 3. And then we get this point and we divide it by 8. We divide it by 8 because 174 comes by taking the addition of 4 points. In the same way, 177 is a summation of 4 points. So together, there are 8 points. So to get the average value we can get for a quarter or for a point, we have to divide by 8. So that's how we get the moving averages. So these moving averages are how we are going to get the trend value. The weighted moving average in the simple moving average, as you can see, we are giving the same amount of weightage. But, the event that occurred 1 year back and the event that occurred like 4 years back will not have the same effect on the current year. The event that have occurred in the closest time period will have a higher impact on determining what will happen in the current period. So therefore, in a weighted moving average, the weightage given to the oldest set of data, the oldest time period is less, and the weightage given to the newest data is high. You can assume whatever the weightage, but make sure those weightage given to the points equals to 1. Here, 0.5, 0.3, 0.2 added equals 1. So here is a 3-point moving average. We are taking 3 points at a time. So quarter 1, quarter 2, quarter 3, those are 3 points. And the weightages are given Likewise. So trend projection. So the amended regression line also will give the trend. Weighted moving average, these techniques will all give us the trend. It will not give us the other points. The seasonal point or cyclical residual, we cannot get by them. As you can see here, y equals a plus bt. T is the independent on the response variable. Time is the response variable, independent variable taken here. B, the slope, that is the change in the predictor variable when the response variable time changes. So if B is greater than 0 means y, the independent, so the dependent variable increases over time. So if we take the dependent variable as a quantity of demand, quantity of demand increases over time. So B equals 0. If B equals 0, that means the dependent variable, as it does not depend on time, it remains unchanged. Even if the time changes, it remains unchanged. B is less than 0, which means over time, the dependent variable is decreasing. Quantity of demand is decreasing over time. That is the trend we can observe. The statistical significance is tested using the p-value of the trend probability. So how significant is the values we have obtained? We can measure it from the p-value, the probability. Let's say we need at least a statistical significance of 5%. So if the probability we have obtained, the p-value we have obtained for this regression is equal to 0, 0.001 or something like that, that is less than 0.5. That means it is much more significant than what the minimum amount of significance that we actually needed. That means we can explain more than 95% of the variation in the demand or quantity of demand from time. The seasonal variation. To get the seasonal component, as I said earlier, there's two models. That's the additive model and the multiplicative model. In the additive model, we take that the dependent variable, the variation is estimated to the addition of those components. In multiplicative model, we are assuming that the variation of that dependent variable is taken explained through the multiplication of those 4 components. So here, assume it's not a data set over a very large period of time. Therefore, no cyclical changes or unusual events can be observed. So in here, we assume that we cannot observe cycle components because it's not a very large data set. Very large data set that for a long period of time, and there's no unusual events. Unusual events that occur during the considered time period. So therefore, we can cut off the cyclic component C and the residual component R. And we are left with a simple equation to obtain the S values in each model. In additive model, you can get the seasonal component by decreasing T, the trend value from the Y value. While in the multiplicative model, you can get the seasonal component by dividing the Y value from the trend component. So usually we are using the multiplicative model. Okay, so therefore, actual value. The actual value we obtained, y, and the forecasted value, t. T you can obtain either using the averaging techniques or the amended regression line. Then you can obtain the component by dividing the actual value by the forecasted value, the trend component. So we have something called seasonal adjustment. So for each season, let's say we have 4 seasons, Q1, Q2, and Q3, and Q4 each year. So each quarter, each season must have the same value. Okay. So the seasonal changes for each season should be same. As I said, seasonal component means it's repetitive. Over each year, the same season is going to have the same value repeating. So it will, and there's also something called unsaid rule if you're using a multiplicative model. If you're using a multiplicative model, the addition of all of these seasonal components, this is the seasonal components of all the seasons, should equal to 4. So we're going to check if it's equal to 4, and then in order to perform the seasonal adjustment, first to do seasonal adjustment, what we are going to do, we have want the all this each season, a particular season in each year to have the same value, no? So what we have to do is add them up. Here, in this scenario, we have obtained the trend component using the moving average technique. And then we are using the multiplicative model, and we have to obtain the seasonal component by dividing the y value from the t value. Then this t value, we have gotten them recorded in a adjustment table. So as you can see, for Q1, the values we have obtained for 2018 and 2019, they are not similar. So what we have to do, we have to add them at these. There are two points. We have to add them together, then get the mean value. You have gotten the mean value, then you're using the multiplicative model. You have used the multiplicative model, so that means there's unsaid rule where all these seasonal components related to each season should be equal to 4, the addition of all these components. So as you can see, it's not equal to 4. So we have to use something called adjustment factor. So in adjustment factor, we are going to divide the number of seasons by the total we have obtained. The number of seasons we have is 4. We have 4 seasons. There's Q1, Q2, and Q3, Q4. 4 seasons divided by the total you have obtained by adding all those seasonal components. And we have to multiply each of these seasonal components by the adjustment factors. If we do that, we will get the adjusted seasonal components. Here we have gotten the adjusted seasonal components by multiplying them by the adjustment factor. And then as you can see, the addition will come up to 4, like we wanted. This is an additional factor. This was done in business statistics. It's an example from business statistics. The effect of the seasonal component. So if it's greater than 1, the seasonal component is the value is greater than 1, that means it's positive. It is less than 1, it's negative. We can see if that has a negative effect or a positive effect. Okay, then we can use these seasonal components and the trend components we found to forecast for the future periods. Seasonal adjusted trend forecasted value. If we know the trend value and the seasonal component, then we can use it to forecast for the future period. Why we say call it the season adjusted trend forecasted value? We say it's the season adjusted trend forecasted value because if you are going to forecast the value of the dependent variable quantity of demand, let's say by using time, by using sorry not time, by using a embedded regression model, um, then what you are getting is only the trend component. So you are assuming that the y is changing, the dependent variable is changing because only the trend component. So that is not correct. So we have to adjust it for seasonal changes as well. That's what we are doing here. That's why we say it's the seasonally adjusted trend forecasted value. So how do we get it? So in here, we are given the trend value. Then for quarter one, the seasonal component is 0.88675. Then y value, if using multiplicative model, y equals trend into the seasonal component. That is 24.5275. Likewise, you can adjust it by if you are doing forecasting using the just embedded regression model. Remember that it's only the trend value and it has not been adjusted to seasonal variations. Here you can see the, okay. We have something called the seasonal dummy variables. We can use dummy variables to create we can use dummy variables to create a model to calculate the forecasted value. Okay. So in here, each seasonal component is given a dummy variable. So we have 4 seasons. One season have to be the base period. So in here, the quarter four season is the base period, and the other seasons are given values. So D1, D2, D3, 3 dummy variables for 4 seasons. Why we are not taking quarter 4 as a dummy variable as D4? It's because uh, normally if both here, as you can see in each quarter 4, you can see all the dummy variables are having 0. That means naturally it is quarter 4. That's how you take it. So here we have assumed a certain data set. We have the quarters, we have the sales values, Quarter 1, quarter 2, quarter 3. Those are the dummy variables. Quarter 4 is the base period. So after running the regression model for this data set, we can estimate the regression function. The regression function as like this. So here, this is the impact of quarter 1. This is the seasonal component. The seasonal component of quarter 2, seasonal component of quarter 3, and the rest is the component of basically the base period value. So you can use this regression model using seasonal dummy variables in order to estimate the demand function. Like directly, you can use this regression model for your forecasting purposes. Just you have to just give whether if it is a quarter 1 value, then you get the 1. Then if it is quarter 1, then the quarter 2 dummy variable will be 0, quarter 3 will be 0. Then time period you have to give time period forecast. Likewise, the forecasting will be easier if you use the seasonal time variables and create this regression model.